Hello everyone. So today we are starting with a new question. Find minimum in rotated sorted array. So what does this mean? Let me clear. We have to search the minimum element in the array nums. But what is the point here? The point is that the nums array is sorted, but it is rotated few times. Like you have given an array 1, 2, 3, 4 and 5. You have to find the minimum value. So you can, if the array is sorted, you can just simply return the first element. We have to just simply return the nums of 0. This is the very easy question, but what is the point here, what is the twist here is that the array is rotated few times. Like the 1 2 3 4 5 array originally, when it is rotated 3 times, it has become 3 4 5 1 2. Let me show you. If there is 1 2 3 4 5, it is rotated one times, means the first element comes to last position. It will become 2 3 4 5 and 1. If it is rotated one more time, then it will become the last element, it will become 3 4 5 1 and 2. Now you have to find the minimum element in this nums array. Now our nums array has become like this. You have to find the minimum array in this, but you have to find in O of logN time complexity, because in O(n) time complexity you can easily find it by using linear search. Linear search is the algorithm by which you can find it in O of n time complexity. But the constraint here in this question is that you have to find it in O of big O of logN time complexity. So there is only one algorithm which binary, which give you the result in O of big O of logN time complexity. So you have to make an algorithm which will return the minimum value of the nums array in big O of logN time complexity. So I hope you have the clear idea what we are demanding in this question. So now let's see what we will be doing. I am taking example 2. It is given that nums equals 4 5 6 7 0 1 2. So you have to first take two elements, left comma right, and left is assigned to 0 and right is assigned to length of -1. So left is at this point right now, and right pointer is at this point. So you have to make a basic standard binary search template code which is having left and right. I am denoting L to left and R to right, and we use a simple while loop, and we run that while loop up till left is less than or equal to right. And in this we are using a mid value, and mid is left plus right, integer division 2. Keep this thing in mind that you have to take integer division, not simple division where you get float values. You have to get integer division because indexing is only of integer type 0 1 2 3 4. So you have to take integer division. Its index is 0. Right from white pen, 0 1 2 4 5. So you have to keep this thing in mind that you have to take the integer division. So what we have to do now is that we have to see that if or we can say if nums of mid, if nums of mid is less than nums of mid minus 1, and you have to check one more condition, and mid is greater than 0, then you have to return So what is the catch here is that in whole array 4 5 6 7 0 1 2, you can see that if any value, if it is in sorted increasing order, like it is written 0, then 3, you can see that the mid minus 1 value, let's say this is mid value, let's say this is mid value and it is mid minus 1 value. So you can see that mid minus 1 value is always less than the mid. Now let's say this is mid value, so it will be mid minus 1 value. So you can see that mid value and mid minus 1 value means mid minus 1 value. This value is always less than this value if it is in a sorted order, it is in increasing order. Now if there is any value after this 0, 1, 2, 3, 0, 1, 2, and here it is written 4, 5, 6 and 7. Now if this is mid value and this will be mid minus 1 value, so if mid minus 1 value is greater than the mid value, then definitely it will be the minimum element of this array. It is the condition which will be returning our correct answer. So if you are having any doubt, then take pen and paper and you can do dry run over this given input. You can easily achieve this condition. If nums of mid is less than nums of mid minus and mid is greater than 0, then this is the condition. And why mid is greater than 0? If mid is less than 0, then it will simply return out of range out of index type error. So because if mid is 0 means mid is 0, so nums of 0, it will be having a value. But what will the value of nums of minus 1? Because mid of minus 1 is nothing, it is 0th index. What will be the minus 1 index? It will be nothing. So that's why you have to keep this thing in mind, that mid should be greater than 0. So now let's proceed further and let me show you the code. And there are few lines that I am handling with first. So let me clear that thing here also. Now let's say if length of nums equal to 1, length of nums is equal to 1, then you have to simply return nums of 0. Then you have to simply return nums of 0, means if nums is having only one value, then that will be the minimum value. Or if you are having an array already sorted 1, 2, 3, 4, 5, then how will you check? Then an array is already sorted, you have to check the first value and the last value, means L and R. If nums of L is less than nums of R, then it simply means that our array is sorted. Then you have to simply return nums of L. Here also you have to return nums of L because L is equal to 0. So in both of the edge cases you have to simply return nums of L. So in first line we will write if nums of L is less than nums of R, or if length of nums equal to 1, then we have to simply return nums of L. Let's see the code. Here is the code. If length of nums equal to 1, or nums 0 is less than nums of minus 1, then we are simply returning nums of 0. Now this is the basic template code of binary search. Left and right, 0, length of nums minus 1. While left is less than right, then we are simply taking mid value and we are checking that condition I had discussed. Now what is these two conditions? How we are incrementing our left and right to mid plus 1 and mid minus 1? We'll see. Now let's say you are standing at this position. Let me first erase all this. We are standing at mid. This is our mid. Now you will see that the mid minus 1 value is not less than, like this is mid value and mid minus 1 value is not greater than our mid value. Mid, I'm simply returning this as M. This is our mid value and mid minus 1 value means this value is not greater than our mid value. So what we have to do? We have to just simply increase the left our left was earlier this, we have to increase our left to mid plus 1. We have to increase our left to mid plus 1, or else we have to decrease our r to mid minus 1. So it will help in choosing the array wherever our minimum value is lying. If our minimum value is lying in this portion, then it will simply it will simply select this much array. And if in any case our minimum value is residing in this array, like the other half of the array, then this condition will simply gives us the edge values of this array. So this was the simple code, and you can see all the test cases are running fine. Let's submit. Yeah, you can see all the test cases are working fine. I had tried this question earlier. I was taking a lot of time. I was stuck, but now it has done. So yeah, okay.